Okay. So today we'll basically be talking about statistics. So I'm sure you can hear me, right? Okay. So I'll just be talking about statistics basically. So in the field of data science generally, um there's a lot of mathematics that goes on within statistics, that goes on within data science basically. And some of those mathematics and some of those numerical computations and all of that are gonna be kind of summarized into the statistics I'm gonna be talking about. So for the stuff so for the stuff I'm gonna be talking about today, I'm most likely gonna be talking about the basic mathematics and all that you will need for the statistics from AI in general. Okay.
Okay. Hi, girl.
Who is that?
No, come let me use I'm coming. Just give me a minute.
Huh?
Just give me a minute. I don't know where this noise is coming from.
I said, fine girl, no pimples.
Okay. So
when you come back,
generally,
if you come back, I'll call you.
Oh Jesus.
Yeah, actually. You see like that.
I think it's coming from Splendor J.
Network is bad.
I don't know where this noise is coming from. And it's really affecting.
I said, network is bad.
I'm coming. Let me just look for the noise where this noise is coming from. I'm sorry. Yeah, I think the noise is over now. So we are good to go. So sorry for that. I'll just be going through my slide quickly, and I will also, at the end of this stuff, I will give an intuitive explanation on how this basic statistics works in the field of data science. I'm going to be more intuitive than coding and technical stuff. So basically, in the field of data, there are many kinds of statistical knowledge that are needed to get a good grasp of how data can be used to provide solutions. Now, there's the regular ones like mean, median, mode, distributions, etc., and all of that. But these generally are some of the very basic mathematical knowledge you will need if you are going into the field of data science. Knowledge of mean, median, mode, distributions, and all of that. Now, this stuff, I know some of us must have learned this stuff in school and all of that, and we may have basic knowledge of it. But when you're actually applying them in the field of data, the decision to know whether to use mean, mode, or distribution or some other stuff is most likely going to be based on your own intuition. It's never as easy as it is this and it is that. Okay, so I'll give you some of those examples. It's never as easy as, okay, a sum of one will take a statistic of a group of people. We'll decide to use mean, fine. We'll decide to use mode, fine. It's most likely going to be based on your own intuition. It's never that simple as A or B or C. So I'll be going through all of that, and I will be giving examples as I go through it. So okay. So basically, I will start with mean. Now, some of you might say, okay, mean is basically the average of simple various values, and let's say we have, let me do this, okay. So we have 3 values now. If I say 3, let's say 6 and 3, 6 and 9, and I say we should take the average, what would just do? You say what? And I say you should take, I want to say an average, I will say you should tell me something about these people. Now, average is a good way to give a statistic about a set of numbers. Now, we can say 3 plus 6 plus 9 divided by 3, that's 12, 18, divided by 3, that's 6. Now, generally, when someone tells you to give a statistics of a data set, what they're actually telling you to do is to generally find insights or tell me something I don't know about this data set, something that makes sense, something that is intuitive to understand. Okay. Now, let's work with something like a very simple analysis. Let's say we have a group of men, okay, and I want to give a statistic of those group of people. Okay, let's say an analysis of those group of people. Now, let's say we have 3 people. Let's say we have Elon Musk. Okay. We have let's say we have Iyobosa. Okay, that's me. And let's say we have let's say someone else, John. Okay. And we have let's say someone else, let's say Grace. Okay. Now, this is the names of people. Okay. This is their net worth. Now, let's say Elon Musk is, let's say what, let's say 200 billion. Let's say, okay, sorry. Elon Musk is probably worth 200 billion. And then we have Iyobosa here, who's worth, let's say 100,000. Okay. Have Grace here is worth, let's say 50,000. And then you have this guy here, which is what, maybe 200,000. Okay. Now, what I'm going to do, what this example is basically doing here, is to help you understand cases where it's not as easy or as simple as taking mean, finding mode, finding stuff. Okay, finding mean, finding mode, finding median, and all of that. So, first thing first. When you are building a statistic of a data set, when you are building the statistics of a data set, the way you do it is that you will give a solution or an analysis that is very easy to understand at the first look. Okay, at the very first look, it has to be easy to understand at the very first look. So let's say we have this simple data set now. Okay, now if you come and tell me, and I ask you to tell me something about this data set, you can say, okay, let me do something like this. Let me find the mean of all the wealth of everybody here. Okay, you can say, if you come and tell me 200 billion plus 100,000 plus 50,000 plus 200,000. Okay. Sorry, give me a minute. So if you come and tell me that the statistics of people is the mean, if you come and tell me that it's the statistic of these people, the mean is so and so value, you've naturally not told me anything. Because if I take the mean of these values here, it's going to be so much less than the values of each of these persons here. So if I tell you that the mean of Elon Musk, Iyobosa, John, and Grace is maybe, let's say, 50 billion, because of course, these values here are not going to be very significant if you are talking about billions, where billion is. So the idea is that if I give you a statistic and tell you that the mean is this, I've actually not given you any useful information, because this mean here is going to give a very distorted understanding to the person that's going to see your statistics. If you are taking a mean of a data set, the mean should be able to convey something important. I should be able to think, okay, if you are telling me the mean of set of values is 50 billion, that means the range, the data set, all the values of the net worth of everybody in the data set should be around maybe 20 billion to maybe 20 billion to maybe around 70 billion for me to arrive at something 50 billion. So if you tell me generally that the worth of a group of people without me seeing this, because I'm not going to see this, the person that you're showing the statistics to is not going to see this. All you're just going to see is this, the mean. And you tell me the mean is 50 billion. What comes to my mind is that there is a set of persons, the data set contains a set of persons that maybe has the net worth of around 20 billion to maybe 70 billion. And so you now took the mean to be around 50 billion. You understand what I'm saying? So this value that you're giving me here has already given me a distorted notion of the kind of data set you worked with. Okay, so in this kind of situation, a mean is not a good way to analyze this kind of stuff. So another way, a good way to analyze this kind of stuff is to maybe show a graph or a plot that just how do I put it now, or a table, just show this table like this directly on the analysis you are working on. Just show this table on the analysis you're working on without actually working towards mean. Mean may not actually give any much of an information. So that's basically one thing about mean mode and data set. Sorry, I hope I'm making sense. Somebody please let me know if I'm making any sense. Just drop a comment in the section. Please let me know if I'm making sense. Just drop a comment, please. I want to be sure everyone is following so I don't say a lot of things and at the end of the day, I didn't make any sense. Hello, just drop a comment in the section if you understood what I just explained. Okay, so thank you very much, Henry. So, okay. So, another thing is, okay, there is maybe multiple ways of actually doing analysis with statistics in data science. There's multiple forms and methods and all of that. So I'm going to be running through some of them. Okay. So one of the first methods of analyzing a group of data sets, or let's say a particular column of a data set, is to find the standard deviation. Okay. Now, what standard deviation basically does is that it finds how much do these data sets vary with each other. Okay. How much do these data sets vary with each other? That's basically what it does. Okay. Then there is also variance, which is quite similar to standard deviation, but variance is more of a higher standard than standard deviation because variance works with the square of the distances of the difference between them. So I'm just going to give you a simple example of how it actually works. Just a simple example. So let's say we have a group of numbers. Let's say 3. Let's say 1, 2. Let's say 3, and let's say 4. Okay. Now, the mean will most likely be 1 plus 2 plus 3 plus 4 all over 4, right? So that should be let me see, 6 plus 4 divided by 4. That should be like 2.5. Okay, that should be 2.5. So if I want to not get the standard deviation of these values, what I'll do is to say, sorry. So what I'll do is to say 2.5 minus 1. Sorry, 1 minus 2.5 all squared plus 2 minus 2.5 all squared plus 3 minus 2.5 all squared plus 4 minus 2.5 all squared. Then what I'll not do is to take the mean of everything. Let's say 4. Okay, this is then you not take the square root of everything also. So I don't know how I'll be able to show square root here, but I'm sure you understand what I'm saying. So normally in mathematics, we just do raised power 1 over 2. So this is basically how standard deviation actually works. Now, what this value is going to give you is going to give you like a summary of how the various values are separated from each other. Okay, how much do they separate from each other when compared with the mean of their values? Okay, so the difference between this and variance, the difference between this and variance is that with variance, you are not taking the square root. That's basically the major difference. With variance, you're not taking the square root. So if you look at it here, this is square, and standard deviation, you are using square roots, okay? So that's basically the difference between both of them. So that's it for that. So there is okay. So if you have a set of values, okay, and the difference and they are spread apart in the range, okay. Let's say I'm talking about something like you have a set of values and maybe the minimum of those values is 1 and the maximum is 100. The way you get those values, if you plot them on a graph, is going to be quite different from when you're plotting a range of values that have between 2 and 50, okay? The difference is that the one from 1 to 100 has a higher spread. It spreads to a higher range than the one between 2 and 50, okay? So this is like a a graph that shows the how the values look like when you plot them on a Gaussian plots, something like that. So this one here shows a higher spread, okay? The range of values, the values are larger, and this one shows a much lower spread, a lower spread of values, okay? So we can see that these values have a higher standard deviation. This kind of graph has a higher standard deviation than this one, okay? So that's basically that. So another thing. So any questions for me there? And let me check the chat. So any questions for me there? Let me quickly mute something. Any questions for me? Any questions? Okay, there are no questions. I'll just move on. Okay, so another very important stuff in statistics is probability. Probability is so much important. It's so important, whatever you are doing. The reason probability is so important is that at the very core of data science, it's mostly about your ability to make predictions. That's one of the major difference between data science and data analytics, okay? And data science, one of the major things within it is machine learning. And your ability, the major reason you are doing machine learning most of the times is to be able to predict results. Okay, let me quickly answer this question. What is the implication of low and high standard deviation values? Okay, it really depends on what you're actually doing. Really, it really depends on what you're actually doing. So let's say, okay, let me just talk about outliers. To answer your questions, I'll talk about outliers. Okay, I'll talk about outliers. Let me just show you this. So to answer that question, I will talk about outliers basically. So, what example do I use now? Let me use an example of, let's say, you have a series of students, okay? You have a series of students. Let's say you have student A, you have student B. Let's say there's an exam, okay? Student A scores 30%, okay? Student B scores 40%. Student C score is 23, okay? Student D, let's say the score is 55. Student E, let's say scores maybe 89. And student F scores maybe 21. Okay? Now, you would agree with me. You would agree with me that if we look at these results like this, we can basically agree that the majority of the students failed the exam. Okay? Because 30 is most likely failure, 40 most likely failure, 23 most likely failure, and 21 is most likely failure. This guy is more like an average, maybe in between, but it's still not very okay. Now this 89, okay, let's make this guy extreme. Let's say this guy is very clever. Let's say he scored 95, okay? Now, there are cases where, okay, this is kind of example now. If I take the standard deviation, let's say I want to see how much how much these results vary, that's the standard deviation. What I'm going to do is I'm going to use my normal formula, right? But the problem will arise because there will be a problem. The problem is arising from the fact that this guy, and this guy are all within the same range. But this guy is just over the top. Okay, so if I take my standard deviation like this, I will get a result that shows the values are spread for a higher range. Okay, that's the values are the standard deviation I will get to be very high. Okay, now, like I said before, if you are given a statistics of a series of values, like which is data science, what data science is mostly doing, you are given a statistics of a set of values. When I tell you that the standard deviation because let's assume you are working with, let's say, thousands of results, we are not working with just 6, because these 6 now you can easily see what is inside the data set. Let's say you are working with 1,000 results. Now, if I take the standard deviation of those 1,000 results, I'm going to get a higher value, because this 95 here is distorting the range of the data set. Okay. Now, this 95 here is something we call an outlier, because it's outside the normal. Okay. Now, if you take the standard deviation of this set of values, you will get something that is actually mathematically correct, but intuitively shouldn't be so, because this guy is just someone else. You can't tell me, if I come to the class, I can't say because one person passed. Just because one person passed, I can ask you, okay, it's a good, the result is good. Understand what I'm saying? So one of the implications of having a high standard deviation is that it allows you to actually check
Like you do physics yourself. Like why?
you have outliers that should be in your analysis. Because this guy is an outlier, then it shouldn't be your analysis. It's just too much. It doesn't tell much. Okay. So that was the basic one of the implications of having a high standard deviation. It allows you to go back to your data set and see if there are cases that shouldn't be in your data set, things that you can remove, because it doesn't really say much about your analysis. So did I answer your question? Can you let me know if I answered your question? Okay, so I'm gonna assume it's okay. So okay, so sorry. I'm gonna go back to the slide now. Okay. So okay, back to probability. So in probability, what we are mostly concerned about is the ability to make predictions. Is one of the very core concepts in data science, your ability to make predictions. And if you're making predictions, there's going to be a level of uncertainty in whatever you are doing. There's going to be a level of uncertainty in whatever you are doing. Now, with data, with probability, we can actually measure our level of uncertainty in whatever we are doing. Okay. Now, in basic mathematics, okay, probability is between 0 and 1. 0 means not very likely, and 1 means most likely. Okay. And the way I'll give a very simple scenario. Let's say you have a data set of previous weather conditions. Let's say 2 years back, and you're now asked as a data scientist or as a machine learning guy, do some analysis on this data set and tell me if there's most likely going to be rain tomorrow. Okay. Now, when you do your analysis, the best way to provide your results, okay, is going to be in a probabilistic format. That is, let's say a range of values between 0 and 1, or a particular value between 0 and 1, where you're going to tell me if the value is mostly closer to 0, you can tell me, okay, it's most likely not going to rain tomorrow. The value is closer to 1, it's most likely going to rain. So that's one of the very few instances where we use probability. Now, in probability, there's various theories that you can use for analysis in probability. There is naive Bayes, which uses previous how do I put it now? Previous knowledge, and just transcribes it to give you future predictions. Okay. Now you can read that of naive Bayes. There is also how do I put it now? There's many probabilistic functions. But my main aim here is to give you an intuitive understanding of this stuff, not to go deep into the technical stuff. So intuition is my major concern here. So okay. So there's also distribution. Okay. Now, distributions are a series of values that have a particular kind of connection, okay, or a particular kind of variation. That's what distribution is mostly about. Okay, so I have chat here. Okay, so Rachel is saying she can't hear me. Is anybody here hearing me? So I can be sure. If you can hear me, please just let me know. I want to be sure everyone is following. If you can hear me, please let me know in the chat section. Hello. Okay. Okay, thank you very much. Thank you so much. And please, if you have any questions, don't hesitate to ask as I'm just talking so that I can just respond on it. Thank you very much. Okay. Thank you. So I think, Rachel, I think this may be from your network, or you can actually, I think it should be from your network. But thank you very much. So distributions, like I was saying, so the distribution is a series of values that have a particular kind of connection within them. Okay, there's a particular kind of connection within those values. Okay, so for a very basic example of what distributions are about, I'll just give you a very simple scenario where distributions actually work like data science. Okay, now let's give a very simple scenario. You are you are an engineer, okay, and you are in the field of let's say you produce nails, okay, you produce nails, that's nails for carpentry work and all of that. And then because your specification is okay, produce 350 let's go very, very simple. Okay, let's say nails that are okay, short nails, let's say 4 centimeter nails. Okay, you have been told to make 4 centimeter nails. This is your guideline, okay, to make nails that have the length of 4 centimeters. Okay, now because of various things that could happen to your machine, maybe you make 10 nails. Let's not go too far. Let's say you make 5 nails. Okay, this is what you produced. Okay, now let's say your first nail had a length of, let's say, 3.97 cm. The second one, let's say 4.04 cm. The other one, let's say 3.88 cm. And this one, let's say 4 points, okay, 4 points, let's say 11 cm. And then this guy, 3.99, okay, cm. Okay, so you've produced, this is what you produce, the 5 nails you produce. Now, because 4 centimeter is actually a guideline, it's almost impossible to actually get that based on the kind of machines you have. Okay, now in this kind of scenario, now because we have a very small data set, just five scenarios, 5 examples, it's not going to give, we can't really plot graphs and see detailed description of what is happening here, because this is just an example. Okay, now let's say after these kind of nails we made, after making these nails, the kind of, if you say you want to plot this stuff on a, let's say, Gaussian, let's say on the plot, what you might be seeing will most likely be a graph of this nature. Let me show you. A graph that is of this nature, where most of the values will be around 4. 4 will be here, and then there will be variations before and after. Okay. Now, that kind of distribution, we call it a Gaussian distribution. Okay. Now, what a distribution helps you to understand, it helps you to understand, again, it helps you to understand the spread of the data. Okay, it helps you to understand the spread of the data. Now, of course, when you produce nails that are of this varying length, okay, now you will understand that it's a technical error, right? But as a data scientist, you should understand that the technical errors you should have should be within a particular range. It's very important that the variation should be within a particular range. Now, how do you decide if, sorry, how do you decide a particular range for, how do you know what range is particular, what range should make sense? It is a one way to look at it is to take the mean of your entire, of the length of everything you've produced and see, is this mean really close to 4? If it is close to 4, that means I'm doing well, my production is quite okay. Okay, now the mean will tell you one thing, it tells you whether your production is quite okay. Okay, then the spread will not tell you your distribution, or your plot will now tell you how much of my nails I'm producing are outside the boundaries of what I'm supposed to make. Okay, so if I go back to that graph, this graph here, if I have nails, let's say a lot of nails that are within this range, because I want most of my nails that are produced to be within this very close value here. Okay, if I have a lot of nails that are produced that are outside or that are very close to the edge, I will know that I'm actually doing something wrong. Okay. So what I'm basically saying is that the thing called data science, we do it, this kind of analysis, we do it normally in our everyday lives, but we not actually know that it's actually data science. These are the basic intuitive parts of data science that we mostly work with every day. Okay. Now, before I continue, I would like to say something. In data science, it's one thing to know the mathematics and okay, I know how to use pandas, I know how to use NumPy, I know how to use matplotlib. It's another thing to actually solve problems with data science. Okay, and when you're actually solving problems with data science, you begin to realize that knowing NumPy, knowing pandas and all that, they are not even enough, because anybody can know NumPy, anybody can know pandas, anybody can know those technologies. But solving problems is another ballgame entirely. Okay, so even in the market, even in the job markets, knowing the technologies will only grant you the interview. That's the best. I think that's the best. Knowing the technologies can grant you the interview. If you're getting looking for a job, it's mostly the interview. But how you are going to survive in that job is most likely going to be about how much intuition how much understanding do you have about this concept? How do you understand? How much understanding do you have of uniform distribution? How much understanding you have of Poisson distribution? Okay, I'll give you a very, very simple scenario. I'll give you a very simple scenario. Say there was something I actually, okay, I'll just give you a simple scenario. Now, you have a let me open my Excel file again. Let me open my Excel file. Sorry, I'll be deviating a bit, but I just want you to understand the reason why the intuition is super important. Understanding these things to the very core is super important. Okay, now let's say we have a team. Let's say Uniben Baskets Ballers. Okay, that's the name of the basketball team. Okay, now we have a lot of stars. We have guys that are winning streak. Like, okay, no, I don't know a lot about basketball. Let me go towards football, please. I don't know too much about basketball. Okay, let me just go towards football. Okay, football will be better for me to work. Maybe football team. Okay, that's the name of the team. And then we have a lot of stars, people that are good, people that have been scoring 5 goals in one game, people that score 3 goals in one game, people that score 2 goals in one game. Now, you have been asked. Now, you are a data scientist. Now you have a new guy coming in that nobody knows before. Okay, he's not in the normal Uniben football team, that's the official football team and all that. And then he hasn't played any game officially. So you most likely will not be able to rate him with what you've done before, unless you have nothing about him before. Now you have been asked as a data scientist, can you tell me how much do you think, how many goals do you think this guy will score in his first game? How many goals do you think this guy will score within the first 15 minutes? How many goals do you think this guy will score in the second 45 minutes and all of that? Now, you will not look at the previous, what do? You look at the previous data set that you have. The previous data that you have about previous players and all of that, okay? Because that's the best you can do, basically. So you look at the data set of the previous players and all of that, and then you think over, what data can I extract from the previous players and use this to give a prediction about how this new guy that nobody knows anything about will behave. Now, the problem with saying, okay, I don't know how much we can do. Okay, let's see him play one game first. Okay, let's see him play one game first. Now, if you say, let's see him play one game first, and then he plays the first game and he scores 1 goal. Okay, let's say he scores 1 goal. Okay, now, if you say you want to take, okay, how many goals this guy scores per match? Okay, now, this is games played. Okay, and this is goals scored. Okay, now in his first game, let's say he scored 1 goal. Let me say he has only played 1 game. Now, if you want to tell me the goals per game of this new guy, it's very simple, right? Goals divided by games, number of games, right? So you just tell me 1/1. Now, this is a scenario where he actually scored a goal on his first match. Okay. Now, oh, sorry. Let's say it's 1. This is actually a scenario where he actually scored 1 goal in his first match. Now, let's say we have another guy. Let's say he scored 0 in his first match. Okay. I don't know what's wrong with this stuff. So she didn't give me this. Okay, let me use here 1. So let's say we have another guy that scored 0 in his first match. Now it goes per game will be what? 0 divided by 1. That would be what? 0, right? Now, if you look at this stuff I just showed you here, the discrepancy is going to be very high. The discrepancy is very high because you are trying to tell me that from just 1 game, you've been able to know the number of goals this guy will score per game for the future. And if this guy, you are telling me that this guy will score 0 goals per game for this match for the future, and they are telling me that this guy will score 1 goal per game in the future. So it really doesn't tell much. It doesn't really give any useful information. Now you may not know this, but this is actually how it is. It may not really give, this thing is not actually giving enough information. So one way to do this is, one way to solve this kind of discrepancy is to actually use a method or a particular distribution called beta distribution. Okay. Now with beta distribution, I will be showing you. Sorry. Now with beta distribution, you can actually use a proper way of using previous data set to analyze how things are going to be in the future for this guy. Now, I wouldn't go too much into beta distribution, but you can basically go and read that one. But what I'm just trying to let you know is the intuition behind stuff. So let me know if I made any sense, please, in the comment section, so that I will know if people are still following me. Sorry, I will be saying too much now. Please, if you're still following me, please just let me know in the comment section. Please, let me know. Thank you. Just drop a hi or anything in the comment section. Okay. Okay. Thank you very, very much. Thank you very much. Thank you so much for the responses. Okay, so back to my slide. That's basically it for that. So for scaling is particularly a method in machine learning where we actually reduce a kind of say we have a data set that contains multiple features or multiple parts to it, and we want to build a model or something that can predict. What we actually do with scaling is that we try as much as possible to reduce all the multiple features to a particular range. Okay. So how do I explain? Okay, let me just give a random data set. Okay. Okay, no, I'll do this in the end because I want to actually use one particular example to explain everything here in a deep sense. So let's just go on to the end and I'll discuss everything again once after. So regression is basically a mathematical approach of combining multiple features together to give more like a prediction. Okay, it's a mathematical process. Okay, it's used in machine learning. So regression relates a dependent variable to one or more independent variables, e.g. the time you get out of bed is dependent on when you went to bed and how long you slept. Okay, so it is x and y are independent variables and z is a dependent variable. Okay, someone asked if what is beta distribution. Okay, a beta distribution, it's a distribution in the sense like it's also more like Gaussian distribution and Poisson distribution. So what it allows you to do basically is that it allows you to use previous knowledge of previous examples, okay, to work with an example you actually have no experience with. Okay, so this is just a very simple explanation of it, but if you actually go underneath it, there's so much mathematics and various properties and all of that within it, but you can basically just do a a Google search on it and read more about it. So that's basically about data distribution. If I want to go deep into it, that means we have to go into the mathematics and all that, which I'm not sure we really have time for. So I really hope I answered the question. Thank you, Aisha. Thank you very much. So, so back to regression. Okay, regression is like the very basic fabric of machine learning. Okay, now I'm sure you all know what machine learning is. Machine learning is about using data to make predictions, building models that allows you to use previous data to make predictions of the future, things you don't have experience with. So regression is a very basic part of that entire process. Regression allows you to combine multiple features together mathematically to give a particular output. Okay, so before I go into the discussion section where we ask questions and I answer, I'll just give one brief example of how regression, scaling, and maybe distribution and everything actually works together. Okay, so my aim here is to actually motivate you to go back and do more on data science and machine learning. That's basically my aim here. So I'll just give a very simple example. So you all will have to follow me, please. Please, I really need you to follow me here. Okay, so I'll use a very simple example that we are all familiar with. So like I said, my aim is to give an intuitive understanding of everything here, because everyone can easily read the mathematics and everything, but so some people. So let's say we have a man, Mr. Taiwo. Let's say we have let's say Mr. John. No, let's say Mr. Uyi. Okay, Mr. Uyi. Okay, Mr. Uyi is a businessman. Okay. Okay. So Mr. Uyi is a businessman. Okay, and he has a shop where he sells. Now, when Mr. Uyi closes from work, he goes home, meets his wife there, she eats dinner, and then goes to bed. Now, we are going to be building kind of a simple model to understand, to predict the happiness of Mr. Uyi by the time he goes to bed. Now, we are going to be assuming happiness is measurable numerically, can be easily measured. Okay. Now, there is three features that determine how happy Mr. Uyi is going to be when he goes home and goes to bed. Okay, let's say the first one is how much, let's say sales for the day in Naira. The sales for the day is going to determine how happy he's going to be, is one factor. Then let's say how sweet the food his wife cooked when he got home is, okay? How sweet the food is, okay? Okay, that's the second feature, okay? Remember, my goal here is to be intuitive as possible, as much as possible. So you are going to forgive me if I'm using a lot of stuff here. So sweetness. Then there is the third factor. What third factor we're going to use here now? Let's say, okay, he checks his kids' assignment for the day and see how much they scored. Okay, how many scored? So let's say their score for the day. Let's say in maths. These three things are going to determine how happy Mr. Uyi is going to be before he goes to bed in the evening. Okay. Now, let's give a range of values for this stuff, how they usually happen. So let's say the max, Mr. Uyi, max and the mean. Let me use max and mean here. Max and mean. So let's say the maximum, okay, the maximum amount Mr. Uyi has ever sold in a particular day is let's say 100,000, and the minimum is nothing at all. Let's say okay, let's use zero in Naira. Okay, this is in Naira. Okay, so let's give a value for sweetness of the food. Let's say the maximum is 1 for a sweet food and 0 for a food that is not sweet at all. Okay. Now let's say the score the children get, let's say the maximum the children can get in the scores is 10, and then the minimum is 0. Okay. So just follow me. I think we are getting somewhere. Okay. So these are the kind of the data set, the maximum and the minimum that can happen for sales, for the sweetness of the food the wife cook, and then the score. Now, let's say on a particular day, let's say today is Monday, Mr. Oyi is going home from work and then he's going home with 50,000 naira. Okay. Now, the sweetness of the food the wife cooked this evening is, let's say, 0.2. Not too sweet. Let's say his children scored 7/10. Okay. This is one particular data set just for one day. Okay. Now, from here, I'm going to give a brief explanation of what scaling is that I described, regression that I described before. And I'm also going to talk about some various things, distribution and all that, all from this example. I'm going to make it as intuitive as possible. Okay, now this is one particular day. Okay. Now, what our aim here is to determine how happy Mr. Oyi is going to be. Okay. That's assuming we are beginning machine learning model. How happy Mr. Oyi is going to be from this scenario that we've painted of Mr. Oyi. Now, let me go back to that slide so I understand something. Where is that on? Okay, so let me just do it this way. Okay, so if you look at what I'm doing here, if you look at this slide here, you'll see I said X and Y are independent variables and Z is the dependent variable. Okay, so in this case, X here can be the sweetness of the food, and Y here can be the amount Mr. Oyi sold. Okay, now if you see this A and B here, this A and B here, I used to weigh the inputs so that we can get a proper output. I will explain what that weighing is in the example I'm giving. So, okay. So, now we have three values. Here. Okay, three features. Now, we can say this is our X, this is our Y. Let's say X1, this is X2, and this is X3. Okay. Now, we want to build our model of happiness. Okay. Happiness model. Now, in all these many talk I'm talking about now, how does machine learning, how does this fit into the context of machine learning? Because the example I'm going to give is machine learning. How does this fit into the context? Now, you will agree with me that for a man, out of these three features, you will agree with me that the one that matters the most will be how much the man sold. Do you agree with me? If you do, please let me know in the comment section so that we don't assume things I shouldn't be assuming. So let me know in the comment section, please, if you actually agree with me. Let me know, please drop a comment in the comment section, please, if you agree with me. Okay. Thank you very much. Thank you. So you agree with me that the how much the man sold is going to matter the most. Okay. So, and it's going to matter more than the score. Let's assume the score the children scored is going to be the second thing that matters the most. And then the sweetness of the food is the third most important thing. Okay. So now that idea of matter, which one matters the most, you know that from experience, right? From what you've already experienced or what you've heard or what you've seen somewhere. Now, that experience, we are going to apply it here. Okay, so what I'm going to do. Now, okay, importance. Let me use level of importance here. What matters the most? Now, because sales matters the most, we are going to give, let's say, sales a value of an importance of, let's say, 0.6. Okay. And then we are going to give, because we'll say this one matters second most, we are going to give it a value of 0.3. And let's say we'll give this one, let's say 0.1. Okay. Let me say 0.2. Okay. So this is like level of importance. Okay. We are going to assign this value level of importance. Now, what I'm trying to say is that for you to know, you actually knew the importance based on previous experience. Now that experience in the context of machine learning is what you've learned. That is the machine learning part of it. It is your experience, okay, from previous knowledge, from previous people and all of that, that made you to know that the level of importance for this one should be 0.6, and the level of importance for this one should be 0.2, and the level of importance here should be 0.3, okay? So basically what I'm trying to say is that it's when you've trained a machine learning model that you begin to know which one is more important, which values are much important in predicting the happiness of a man, okay? So that's what basically this is. So these values here now are your A, I we saw in the previous stuff, and this is your B, and this is your C, okay? So now, when you have your features, the way to predict with linear regression is to multiply each value with their importance and then sum everything together. So you're supposed to multiply this with this, then sum it up with this, the product of this, and sum it up with the product of this and this. Okay? Now, that is the, okay, there's some question here. So that is the basic thing about linear regression. But there is one more thing we need to do first. The problem with this kind of stuff is that high and low are relative terms. Okay, they are very relative terms. You understand? In the case of sales, high is 100,000. That's the max. Okay. Okay, someone has a question. Please ask your question, Sheena, please. Sheena, please, you can ask your question.
Hello?
Hello, I can hear you.
It's okay. My worry is this, on the level of importance.
Yeah.
If you sum up the three, it is, because to me, I guess those stand for your probability level. If you sum them up, it will be more than 1. 0.6 plus 0.2 plus 0.3. It should be 1.1.
Okay, yeah, I understand you. But the thing is, the importance are not actually probability. Okay? They are just...
Yes, and this one is it 1.
Yeah, it's not a probability. These values are not probability.
No,
they are not probability. They are used for scaling. I will go there. They are used for scaling, but I will explain that very soon. Just by the time I explain,
okay.
I'm sure you really understand it properly. Thank you very much for the question.
It's okay.
Yeah.
Thank you.
Yeah.
So, since he's
please mute yourself. Thank you. Sorry, let me mute. Sorry.
The exchange, she passing. This time back with the US. This time Lima with the Irish with one day. Lima back with 2. This time back with. See, this time Lima.
I think it's muted now. Okay, sorry for that. So what I was saying is that importance is not probability. I will explain why later. I will explain the probability part of it. I will explain the probability part of it. So now, before we begin to do the multiplication and all of that, one thing, the first thing you do is to rescale your features. That's this guy here. You have to rescale this guy. It's very, very important. The reason we should rescale is because in the mathematics of it, this 50,000 here is going to drive, if we do a multiplication of, let's say, 50,000 now, times 0.6 plus 0.2 times 0.2 plus 7 times 0.3. Okay, now you will agree with me that this 50,000 here is going to drive these values, this answer, very high. Okay, so these values, before we can do this, we have to rescale. Otherwise, we'll have values that are so high that they will not make any sense mathematically. So one of your decision for scaling is usually dependent on you mostly. There's multiple ways of rescaling values. There's the normalization, there is the mean subtraction, there's multiple fashions, there's many. But for this case, I'm going to use a very simple fashion of scaling. I'm going to use percentages. Okay. So for rescaling here, I'm going to use percentages. So what I'm going to do, I'll put here rescaling. Okay. Now, here, I will use, if I'm rescaling, a value of 100,000 will be 100%, while a value of 0 will be 0%. A value of 1 will be 100%, and a value of 0 will be 0%. Yeah, 10 will be 100%, and 0%. Okay, so I'm going to rescale with percentage. So, so here now 50,000 is in between 100 and 0. So I'll say 50%. Okay, that's 0.5. Okay, now a value of 1 is 100, so 0.2 will be what? 20%. 0.5, sorry, 0.2 actually. Sorry. And then here a value of 7 is like 70%, is the maximum is 10. So 70%, that's 0.7. So we have our rescaled value. So what I'll be mostly using is what is in a bracket actually. So if you understand what I meant by this rescaling, please let me know in the comment section. I want to be sure everyone is following, please. Please, if you do, let me know you understand what I'm saying. Just give me a moment, please. Sorry.
Hello.
Okay, so sorry for that. I'm back. So someone said she doesn't understand. Let me see. So Rachel, are you talking about the rescaling part, or sorry, let me understand which part you don't understand. Rachel. Okay, I'll go over the rescaling part again. I'll go over the rescaling part. Okay, so okay, I'll just go over it again. So we have the maximum as 100,000. Okay, the maximum demand can sell is 100,000, and the minimum is 0, right? So since the value we're actually looking for and we're actually working with now is 50,000. Okay, the value we're actually working with now is 50,000. And means this 50,000 is midway between 100,000 and 0. Okay, so this 50,000 is 50% of 100,000. That's why we have 50 here. Okay, and 50% in decimal is 0.5. Okay, so for this guy here, the minimum is 0 and the maximum is 1. But the value we are working with is 0.2. So 0.2 is 20% of 1. That's why we have 20% here, and which is what, 0.2. So same thing here. This value here, 7, is 70% of 10. So that's why we have 70 here. Did I answer your question? Did I answer your question, Rachel?
Hello.
Hello, can you hear me? So, yeah, I can hear you. I can hear you.
Yeah. Is it safe to conclude that when you are rescaling, especially when you want to use percentage,
Yeah.
you find the range, which is the maximum and the minimum. Then you say the actual value all over the maximum times 100.
Yes.
Give you the scale for that particular data item.
Yeah. It's very possible. Now, this kind of scaling I'm doing now, it's a very useful scale. It's actually used in the field. It's called min-max, in case you want to read about it. Min-max scaling.
Min-max.
Min-max, not minimum. Min-max scaling. So you are scaling between the minimum and the maximum. So this basically is how it actually works. So yeah, you can just find the minimum, find the maximum, and then make everything within that range if you're using percentages. It actually works.
It's okay.
Okay, thank you very much. Thank you. So I believe we can continue. Okay, Rachel said okay, she understands that now. Okay. Thank you. Thank you, Rachel. So now we've rescaled. Okay. I'll be working words in the brackets. Now, to actually get a definition of happiness, okay? Okay, this is it. To actually get a definition of happiness, what we are going to do is to say happiness will now be equal to the level of importance multiplied by the rescaling. Now, I will go back to that slide so that you understand the difference. You can see this A and B here. These are the level of importance. These are the values that your machine learning model will learn. Okay, now we give those values 0.6, 0.2, and 0.3 because we have the experience to know that these are what it should be like. Okay, now our experience is more like what the machine has learned. Okay, now this X and Y are our rescaled values of the features we are putting into the model. Okay, so our aim now is to get a value for Z. Okay, so I'll just go back and we'll just do some multiplication and we'll see how the value goes. So this will now be okay, 0.6 times 0.5 plus 0.2 times 0.2 plus 0.3 times 0.7. You see, our value is 0.55. Okay, now this value here gives a value for happiness in a way. Now to break this down, what I'm going to do is there's something called logistic regression. Okay, in logistic regression, what we just did is linear regression. Linear regression allows us to have a range of values as an output. Okay, a range of values. Now, for this value to make sense to you, okay, you have to have an understanding of what maximum happiness is and minimum happiness is for you to know that, okay, 0.55 is close to maximum happiness. You understand what I'm saying? So what I'm going to do now is we're going to practice a bit of logistic regression for you to get the general idea. Now, what logistic regression is doing for us is that it allows us to take, in this case, happiness now, it allows us to measure happiness as a value compared to the maximum kind of happiness that can exist. You understand what I'm saying? We are going to measure it with respect to the maximum kind of happiness that can exist. So this is our predicted happiness now. Happiness, okay? Now, for this value to actually make sense to you, you have to know what is the maximum happiness and compare it with this. So how do we know the maximum happiness? Okay, now, let me increase this stuff. Now, to have an idea of the maximum happiness, now you will agree with me from this data set that we have, Mr. Oyu will be happiest when he sells 100,000 on a particular day, and then the sweetness of the food is 1, and then the children scores 10 over 10 in their assignment. That's by definition the maximum kind of happiness we can have. Okay. Now let's create a new column. let's see here. Okay, maximum happiness features. Okay, so we have the maximum sale the man can make, let's say in a particular day that will make him the happiest, the most happiest the most is 100,000. Okay, and then value here, that's the sweetness of the food is what, 1, and then the score, the children's score is what, 10. This is what makes him the happiest by our definition. So if we rescale this again, because we always have to rescale before we pass into our model. So if we rescale this, we get what? This will be 100%, that's 1.0. This one will also be what? 100, that's 1.0. So will also be what? 100, 1.0. Okay. Now, if we now pass this into our model, maximum happiness, remember this one, what we did there was this times this plus this times this plus this times this. So what we are also going to do is to multiply the importance by the rescaled value. Okay. So what we are going to do here is to get what? 0.6 times 1.0 plus 0.2 times 1.0 plus 0.3 times 1.0. Okay. Now what do we have here? We have 1.1. Okay. Now back to the person that was asking about probability. This is where we're going to use about something similar to probability. Now you can now see that a value of 1.1 shows that Mr. OE is happiest the most. Okay, is happy the most. And then a value, but our calculation, we got a value of what? 0.55. Now, if we want to now get a probabilistic measurement or a how do I put it now? A percentage of how happy Mr. OE is, what we'll not do is not say, okay, we'll not say 0.55 divided by 1.1, which gives us 0.5, which is equivalent to what? 50%. You understand? So we can basically say that from these features we are given now, Mr. OE's happiness is what? 50%. You get the logic? So this is basically what machine learning does for us. But the part here that is machine learning is this importance that in machine we have to learn. There are multiple ways of building this model. There's gradient descent, there is multiple parts. That's just something you can always read outside. But the basic thing you should pick from here is that you will have features in your data sets. Like our features here are what? Sales, sweetness, and score, those 3 features. Then you have a way, this stuff here is in data science, you might not call it, how do I put it? The way you get these values from the data set, because now I just said 100,000 is the maximum, but most times you actually need to get this from the data set that you have. So the way you get this is something we call exploratory data analysis, EDA. You can always read on that. I'll put that in the comment section. So let me see. Okay. You have EDA, exploratory analysis. Okay. That's it. Exploratory data analysis. That's how you get which one is minimum, which one is maximum. Then you will have your particular features, the one you want to test for. Normally, after getting your minimum, you get your maximum, you rescale. Normally, this importance comes from the model you've already trained. Okay, this importance comes from the model you've already trained, like the parameters within the model that the model will use to actually make predictions for you. Okay, now I'll just go over it again. These are your features from your data sets. These are your min max that you get from your exploratory data analysis. Then you rescale. This is your rescaling part. You rescale, but in this case, we are using min max scaling, so we are using percentages. Okay. Then you now train your model. We pass it into your model. So I'm not going to those parts. Someone else will talk about that next week, I think. Then these values are gotten from the model you've already trained. These are like the parameters, but yeah, for intuitive, for the sake of intuition, I'm using importance. So these are what your model will learn. And then when you now do your prediction, like we've done here, you can now use various methods like this technique of dividing by this to get a percentage, understand a percentage of your actual value. So this stuff is what makes sense the most. I'm telling you that the happiness of Mr. Oyi is what 50%. This is what makes sense the most of everything here. So please, if you actually understood everything I've said, please just let me know in the comment section. I think I will end it here. So just let me know if you actually understood everything in the comment section. If there's anything I need to go over. So I'm very sorry I'm not doing coding and all of that, but I'm very, very sorry. So my aim here basically was just to make this thing as intuitive as possible. So let me know if you understood everything I said. So to the man that asked about probability and all of that, I hope you understand. I answered your questions clearly now. If you understood, please just let me know in the comment section. If you understood everything I've been saying, just let me know in the comment section. Okay. How do you get importance from ML? Okay. So okay, let me pick the first question first. Mr. Shina. Mr. Shina says, how do we get the importance from ML? Okay. How do I explain? Okay. In the case of linear regression, when you start, okay, when you say you want to create an ML model, okay, when you say you want to create an ML model, you start by creating an ML model is an architecture of its own, okay? It's a series of parameters, a series of methods, a series of processes within it, okay? Now, when you start with random values. Importance is random values. That's how model starts, okay? They start with random values. When I say random values, like here now, we've been able to show that it's 0.2, 0.2, 0.3. But when you start an ML model, you pick, the model initializes these values with random values. Let's say 0.239, 0. It could even have minus different values. That's how the model initializes. Now, it's when you now pass in your data, that's the data set. Your model will now look over your data set 1, 2, 3, 4, 5 times and learn how to arrange those values that you initialized randomly to get a particular optimal value. You understand what I'm saying? It will learn from your data set. That's the machine learning part. It initializes this importance per se, these importance values randomly, and then it learns from them recursively. That's pass the data in the first time it learns, pass it the second time it learns, pass it the third time it learns. More like how a child learns how to solve mathematics. First example, you may not know it, you may not get the full picture. Second example, third example, fourth example. So that's how machine learning also learns. It picks so same way when you look at a new textbook, you have no knowledge of everything is gibberish. But when you look at it the first time, second time, third time, fourth time, you begin to grasp it one after the little by little until you get a particular an idea, so a general idea. So that's basically how importance comes. Importance are initialized randomly in the beginning, and then the model learns how to tune it to get the particular values. So, but already there will be someone else to talk about that generally next week. So so Sina, did I answer your question?
Yes.
Okay, thank you very much. Thank you.
Thank you.
Okay, so Mr. Henry said it is clear, but how do we interpret the results? Okay, to interpret the results, there is multiple ways to interpret results. So, but in this case, how do we interpret the result in this case that I'm working with now? So let's see. Okay, I think we can interpret it this way. The way to interpret it is this. Okay, the aim of this slide, everything I was explaining this slide, is to actually find a way to predict how happy Mr. Henry is going to be given a particular set of values. Okay, how happy is Mr. Henry going to be given a particular set of values? Now, we've had Okay, we've had these three features. We got these three features of Mr. Uyi on a Monday. We said he sold 50,000. Sweetness of the food was 0.2, and then the score is 7, the children's score in school. Now, what we've been able to calculate here, when we calculated it, we got 50. Okay, so the interpretation of this 50 is that Mr. Oyi's happiness is going to be like most likely 50% of his normal usual maximum happiness. Let's say Mr. Oyi is most happy when he's at the club, or when he's at the club. Let's assume he's most happy when he's at the club. So the interpretation of this result is that we have measured this 50% is that we have measured Mr. Oyi's happiness with respect to his maximum happiness. That's a prediction. Okay. Now, when Mr. Oyi actually gets some, things could be actually different, because the thing about predictions with your ML model is that you can't be absolutely sure about everything. Because in this case, now we are using sales, sweetness of food, and score. There are so many other things that could affect his happiness. There is the fact that in traffic, someone could have insulted him in traffic. That is one thing. It could generally spoil his mood for the whole day. But we are not featuring that into the model now. There is also the fact that maybe when he got to landlord that just come to say, okay, where is your house rent? That would have spoiled his own mood. Okay. So some other features that are not within the data set, those kind of things can actually tamper with our accuracy. So those kind of things, we call them noise in a way. They call them noise because there's so many other things that could affect. So, but you can only do with the data set you have. Okay. So in our case, the data set we have only 3 features. So that's basically it. So the interpretation is basically we've been able to measure Mr. Oyi's happiness as half of his usual maximum happiness. That's the prediction we've been able to make. So I hope you answered your question, Mr. Herring. Okay, thank you very much, Mr. Herring. So Mr. Martino says he hasn't been added to the group. Okay, Peter, I don't know if you're here. Peter, I think you can help me with this. Hello, Peter. Okay, I don't know if Peter is here. But okay, so Mr. Martino, I don't know if you can you, Mr. Martino, can you quickly send me your WhatsApp number through the DM on the chat section? Just send it to me personally, and I will forward this to the person that will add it to the group chat. Just forward it to me personally on this. Martino, can you hear me?
Yes, I can.
Okay, just send it to me DM on the chat. Just send me your WhatsApp number. Okay. I will add it. Okay. So, any other question? If you have any other question, anything I mentioned, any other of that on the feature analysis and all of that, just let me know. Any question? Okay, so thank you, Aisha too. Thank you very much. So since I really don't have much to say, but I think I still have 23 minutes, but I'll just go over some basic things that I don't know. Okay, so let's say you are a data scientist now, you've learned everything learnable, you know all the Python, you know the pandas, you know the let me quickly add this guy. Sorry, give me a minute. Sorry, give me a minute. Okay, so since I still have some more time, I will just talk generally about how these statistics and all of this really work in the field mostly. So you're a data scientist, you've learned all the basic stuff, you've learned pandas, you've learned NumPy, you've learned analysis, you've learned all of that. But how do you actually apply it in the real field? Okay, this is one thing I'm sure it's not really talked about enough in the field. So it's not enough to just know pandas, to just know NumPy, to know this. The intuition about this stuff is most likely very important, because when clients come to meet you, when people meet you, to solve data problems for them. Okay, sorry, someone is asking a question. Okay. Okay, so Mr. Shina, the major difference between linear regression and logistic regression is that linear regression, we are getting a particular range of values. While logistic regression, we are concerned about how do I put it down? We are concerned about measuring something in a form of binary. That's more like yes or no. Okay, yes or no. Now, let me explain it in the case of this system. So now, in this case, when we got a value of 0.55, it was just a value from our calculation. Okay. Now, this is the value you get. This 0.55 is the value you get from linear regression. Okay. This is the linear regression part. Okay. Now, this is just a value. It's a regression. One of the many cases where you use regression, maybe you build a model to, let's say, one of the simplest examples is you build a model to classify to predict the price of the house, given the location of the house and the area of the house, like the space the house occupies, how big is the land, how big is the house, and all of that. So when you get the value, you can just say, okay, the value of this house, we are predicting it to be 2 million. That is linear regression. Okay. When you're predicting linear regression, you have a range of values that your answer can come within. Okay. That is one thing about linear regression. Let's say you are predicting the number of people that will come to class tomorrow as a lecturer or something. Now, you can say 100, you can say 50, you can say 1,000. That's the logistic, that's linear regression, because you are having a range of values that could happen. But with logistic regression, most of the times, we are actually trying as much as possible to limit our values to a particular range to have an understanding of what is going on. Okay, we are trying as much as possible to limit our values to a particular range. Now, one thing with logistic regression is that the aim mostly is to make an intuitive or easy sense of what you are working with. Okay. Now, if you look at this happiness now that we got a value of 50%. Okay. Now, this 50% is we said it is when compared with the maximum happiness. You see, so the yardstick here now, in this case of kind of a logistic regression, is with the level of the maximum happiness Mr. Oye can have. We are measuring this value against this 0.55 against the maximum kind of happiness Mr. Oye can have. That is our yardstick. That is our measure. So in the case of logistic regression now, we are saying that what the value of logistic regression in this case is between 0% and 100%. While for linear regression, the value here can be from 0 to maybe what? 1.1. Can you see the difference? Now, another case where logistic regression is very important is that logistic regression can answer yes or no questions, like binary questions. Okay. Like let's assume when we did the calculation for Mr. Oye's happiness and we got 75%. Okay. Now, we can say because this value is bigger than 50%, we can say Mr. Oye is happy. Okay. We can set a threshold. Let me just explain what threshold is. Threshold allows you to demarcate values. You can say anything less than 50% is not happy, and everything above 50% is happiness. That is one of the ways in which logistic regression works. And logistic regression usually have thresholds in which they work. Logistic regression usually have thresholds. Now, in this case, if we apply a threshold of 50%, like, assuming we did that calculation and Mr. Oye's happiness with respect to his maximum of 75%, we would have said, okay, he's quite happy because it's above 50%. If we are gotten a value of, let's say, 0.2, we can say, okay, maybe it's not that happy because it's 0. Just 20%. So those are one of the basic stuff about one of the major differences between linear regression and logistic regression. So did I answer your question, Mr. Shina?
Thank you very much.
Okay, thank you very, very much. So I think I can. Is there another question? If there's another question, let's any question? Okay. So if there's another question for the remaining 17 minutes, I'll just talk about data science in the field and all of that. So I was talking about before the question, I was talking about you learning data science, learning machine learning, learning Python and all of that. And then you're actually in the field now. So the major thing is one of the best skills you will need to be a data scientist in the field is your ability to not give up. That's the basic thing, your ability to not give up, because the transitioning from working on projects personally to being in the field can be very steep. The learning curve can be very steep. You know, when you learn by yourself, you can learn at a pace of maybe I learned pandas. I'll use 2 months to learn pandas. I can use 3 months to learn on pandas. When you actually get into the field, that pandas, you will learn it within 3 days. Nobody will tell you, understand? So the most important skills you need in the field of data is your ability to not give up. That's the basic thing. Like I said before, your technical skills, pandas, NumPy, machine learning, scikit-learn, and all that, those guys will only grant you an interview. That's what they will do for you. If you have those stuff on your CV and all that, they will only grant you an interview mostly. But your intuition and your ability to learn fast with what will keep you in a job in the case of the job market. So that's basically all for that and all of that. So I would like to ask Peter now. Peter, is there any other thing we would love to share and all of that so we can end the session? Hello, Peter. Okay, so I think that will be all for now. So thank you very much for joining us today. So we'll be back again on Wednesday and on Friday. I'll be taking Wednesday and Friday too. So thank you very, very, very much for joining us today. I really appreciate every one of you. Thank you so much. So we'll be ending the session now.
Thank you very much, sir.
Thank you.
God bless you. Thank you.
Thank you very much.
Yeah.
Thank you very much.
Yeah, thank you.